Hello. In this video, we're going to be talking about how functions can be periodic. But before we get going, we're going to look at the unit circle here and find the exact value for these trig functions. So the first one I have is the cosine of 585. So you're not going to find 585 degrees on this unit circle because a full circle is only 360. And 585 obviously is bigger than that. So if we were to start in standard position and do a full circle, we're merely at 360 degrees. So to get to 585, how much more do we need to go? Well, if we take 585 and take away the 360 that we've already gone around, we're looking at 225 more. So we're going to keep going here until we land at the 225. And so there we are. So cosine of 585 ends up being the same thing as the cosine of 225. And that ends up being, well, the same thing as the value x, so negative square root 2 over 2 is the exact value for that trig function. We can do this again here with sine 10 pi over 3. Well, a full circle is 6 pi over 3, which is the same as 2 pi. So if we take 10 pi over 3 and take away 6 pi over 3, we're looking at 4 pi over 3. So sine of 10 pi over 3 is the same as the sine of 4 pi over 3 that we've just backed off by a circle. And 4 pi over 3 is down here, and sine is the y value, so it's equal to the negative square root of 3 over 2. How about tangent of negative 945, excuse me. Well, again, 945 is not going to be on this circle, but what I can do in this time is start adding 360s on. And if I add actually two of them, so basically I'm adding a 720, I'm looking at negative 225. And so remember what a negative rotation looks like. I have the blue this time. So there's 1, there's negative 720, and then so here that's 900, so 925 would land, 945 would land right there, the same as the 135. So tangent is the same as y over x, and so it's almost the exact same thing divided by itself, except one's negative and one's positive, and so it ends up being negative 1. Now the reason we talk about this is because sine, cosine, and tangent are periodic in nature, meaning after every 360 degrees or every 2 pi units, the values or the outputs for them start to repeat. So let's take a look at some examples of this. On this slide I have the definition for what it means for a function to be periodic, and it starts to repeat itself over a specific interval. And the length of the interval in question is called the period of the function. So in numbers 4 and 5 you were asked to figure out what is the period for each of these functions. Now in number 4 you can see how it really has a repetition like a crest and a valley for each of these. And so if we look like here on the y-axis and then again split it right there, that chunk looks the exact same as going that next chunk there, which looks the same as this next chunk here. Okay, and you can see how within this rectangle that I just drew, that each of these begin or look the exact same. And so what is the length of distance between each of these rectangles? So 1, 2, 3 units over, so the period must be 3. It's the same distance over for each of them. We can do the same thing in 5. Here, if we start there, it repeats after 4 units this time. So you can see how each rectangle looks the exact same. So my period for this one would be 4 as we go over 1, 2, 3, 4 units to get there. Okay, and so that's what it means for a function to be periodic. For now, we are done.